So the first thing we need to understand to develop a physics-based knowledge of bushfires is what actually is fire. How does wood or other organic materials actually burn? Now fire is of course a reaction, exothermic reaction between wood, cellulose and oxygen in the air. And it actually happens in two different ways. One way is directly where the air meets the wood and there's combustion on the surface of the wood. This is a slow burning. It's responsible for embers, like you can see in this picture. Now, that's important in many situations, like keeping warm at night around a fire or cooking marshmallows, but it's not the dominant effect in spreading bushfires. The dominant effect in bushfires is pyrolysis. Now, what is this? Well, when wood gets hot enough, or cellulose, or most any organic material, it releases an inflammable gas. The cellulose breaks down in the heat and releases this gas. And it is actually this gas, not the wood itself, that is burning. That's what produces the yellow flames that you're seeing somewhere like here. What's happening is this wood is very hot. As the cellulose breaks down, it releases the gas flows away, then combines with the oxygen at some distance away from the wood and burns, producing the flames. And this is the one that dominates in bushfires, at least the spread of bushfires. Now, note that if you look up pyrolysis as a word, it's used in two different ways. In bushfire physics, it's used to describe the gas given off by hot wood that then burns. But it's also used to talk about combusting something under the absence of oxygen by some chemists. But anyway, when wood gets to about 400 degrees, it varies depending on the wood and how dry it is, you get this gas coming off, and it's a very inflammable gas. Now, how about flames? You can see flames normally, they're not always. A hydrogen burning flame is almost invisible. Now, if you burn something like natural gas, which is mostly methane, you see a very blue colour. This is actually due to vibrational spectral lines called the Swan bands. Here's actually a spectra of a methane flame, and you can see various vibrations of carbon, hydrogen and carbon produce the blue colour. But that's generally not what you see in bushfires. In bushfires you usually see this yellowy orange colour. And that's actually black body radiation. What's happening is that the fire is not fully combusting and everything, because it's a very complicated mix of chemicals coming out of the burning wood. And so you get very tiny grains of black carbon, soot it's called, too small to individually see. But as these fly through the air, they're very hot, and therefore they emit black body radiation at a temperature of between 1000 and 1200 Kelvin typically. And what you're actually seeing, say this plume of yellow up here, is lots of these very tiny carbon grains heated up to this very high temperature, emitting black body radiation. And black body radiation at these sort of temperatures typically produces an orangey yellow sort of colour. So to sum up, the way you're going to get fire typically in a bushfire is you take wood or grass or any other organic material typically, and you heat it up. You heat it up to over 400 degrees typically, and when you heat it up that much, pyrolysis begins. The cellulose breaks down, releasing an inflammable gas, a rather complicated chemical composition made of many different things. Now this gas will typically fly upwards because of the heat, convecting it upwards. It doesn't have to ignite. If, for example, you put a piece of wood in an oven and heated it up, you get the inflammable gas off, but unless it's a gas oven, it probably won't actually explode or burn. At lower temperatures, it typically needs a spark to ignite it. So you could have a piece of wood that's getting hotter and hotter and emitting all this gas, but if there's no spark, it wouldn't ignite. But when you get over about 600 degrees, it kind of doesn't matter whether there's a spark or not. This will definitely ignite. Once it ignites, it combines with the oxygen in the atmosphere and produces the yellow flame that you actually see, the flame being caused by these tiny carbon grains emitting their black body radiation.